Hey guys, today I'll show you guys how to solve the merge two binary trees problem. This one is an easy one, so hopefully the solution is kind of straightforward. However, one thing I need to know for this problem is that there's a very annoying definition we need to clarify, which can change the way we implement this problem. So the question states that we need to merge two binary trees into a new binary tree, right? And by new, then it says otherwise the not null node will be used as the node of the new tree. So with this definition, right, there's two interpretations. One is we create a new tree, but we can reuse the nodes of the old trees. So for example, any subtrees of tree 1 and tree 2 in our new binary tree. So effectively, these subtrees, for example, in this new merge tree here at this 4, we're using the 4 from tree 2, and we're using 5 from tree 1. And essentially, these nodes are going to be sharing the same exact memory location. So if we ever modify tree 1 or tree 2, it's going to change tree 3 as well. So if they're fine with that, that's one interpretation. We can solve it. I'll show you how to solve that. The second interpretation is in our new merge tree here, 4 and 5 and 7, right? They're all going to be created as new nodes independent of tree 2 and tree 1. All we're going to do is just copy their values down and create a new node for it. So if we ever modify tree 3 or tree 1 or tree 2 at 5, 4, or 7 location, the other trees will not be affected, right? So these are two distinct implementations and differences, and I'll show you how to do both of them. So in the first one, we are basically traversing through the tree together, and if we see one that has a one of the trees are missing a node and the other one has it, then we're going to recycle the node from that point, right? So to just quickly demonstrate that, so we first traverse both starting from the root. We see both of them have values, so we're going to sum it up. Then let's proceed into the left subtree. And we see they both have a node here as well, 1 and 3. We add that up, we get 4. Now let's go down one more time, and we see, okay, tree 1 has 5. Tree 2 does not have 5, or just a node in the left subtree. So therefore, we're just going to take this 5 from tree 1. Similarly, we go to the right side now, and we see that, okay, tree 1 doesn't have 1, but tree 2 has. So we're going to just recycle this from tree 2. All right. And then we go, okay, now we go back up, and now we go to the right tree. We see 2 and 3, good. We have 5. We go to the left, we see nothing. Neither of them have anything, so we don't add anything here either. And then we see, okay, so the tree 2 has the 7 node here, and tree 1 doesn't. So we'll take tree 2 from 7 here and add it here. So in this case, right, we have 5 recycled from tree 1, 4 recycled from tree 2, and 7 recycled from tree 2. And so if any of these 3 trees, any one of these 3 trees gets modified, these values are all going to change as well. Oh, I mean, sorry. If we change tree 1's 5, this is going to get changed to whatever value it is. If we change tree 2's 4 or 7, this is also going to change. So I'll show you how to implement that real quick. So basically, we have some base cases to cover. So if tree 1 is empty, right? If tree 1 is empty, then that means we can use the entire tree 2. If tree 2 is empty, then we're going to use the entirety of tree 1. Now, if none of them are empty, then we're going to create a new node for it, and we're going to maybe call it a new root, and tree node of the sum of the tree 1's value plus tree 2's value. All right. And now we need to start merging the two trees together. So what we'll say is, okay, I'm gonna create my new left node here. So in this example, okay, I'm gonna go down left now. I need to merge the subtree from tree 1 here in the subtree from tree 2 here. So we're going to take the left of tree 1 and tree 2 and do a recursive call using the same method, merge trees, right? And then we're going to say, okay, I'm going to merge T1's left and T2's left now, okay? And then we're going to say the same thing for the right side. We're going to now merge the trees of the T1's right and T2's right. And you might be wondering, okay, what happens when we hit this case, right? When we say merge tree 1's right, but there's no right value. If we see that, we know that, okay, we just return T2, and T2 at this point would be just 4. So we're going to just give back 4 from tree 2. So we're going to recycle the subtree from the other tree in there. Right? And then hopefully that makes sense. Now, the other solution, which is creating a completely new tree in which that these dependencies are no longer existent, so we remove them, right? So remove all these dependencies here. It's completely standalone new binary tree. And then this one requires a bit more work, but let me show you. So in this second approach, we need to say if T1 is empty and T2 is empty, right? If both of them are empty, then we return nothing, right? We cannot create a new tree from 2 empty trees. Now let's create a new node here called tree node, and initialize the value to 0 as from this definition here. Now what we're going to do is we're going to say, okay, if T1 exists, then my root value is going to be adding that value to my new root. So I add T1's value to it. And if T2 also exists, then my root value will get also add T2's value to it. Okay, now here's the interesting part. Now we need to traverse the trees. Basically, what we're going to do is we're going to do one pass through the first tree and basically copy it into our new tree. Then we do a second pass over the second tree to start like iterating and merging those values into our new tree. So our first iteration is going to do this, and then we're going to have some existing nodes here, and then we're going to check, okay, if there's an existing node, we need to do a summation. If there's no existing node, then we're going to do we're going to create a new node, right? Instead of recycling the new node. So for this example, if we use tree 1, we'll copy it over. Let's say, okay, that's great. And then we sum up to 2, 1, so that's 3, 4. And now we have 5, and then we have 4. So if we copy over tree 1, we see that the 4 does not exist. But we see that the 4 exists for node of tree 2. And what we're going to do is we're going to create a new node here and add the value in instead of recycling this. And then the same thing for 7 here, right? So basically that's how we're going to do it. But I'm actually going to create a new helper function here that's going to help traverse. And it's going to take in our new binary trees node, and it's going to take the other trees, the other tree, either it could be tree 1 or tree 2, to traverse. So if the other tree is empty, we'll just return. We don't do anything. Now so here, let me write some comments. So okay, now where other is empty, so it could be any node. If the other tree's left node exists and our new tree contains, or let me change the definition here a little bit. If the other trees has a left node in this location at this point of our iteration, and our new tree also has a left node in this location, we just add the left node, the other trees left node value. All right. Now, otherwise, if the other tree left node is in this location and our new tree doesn't have one, then we create a new one, right? And then same for right side as well. Cool. So let's code this, right? And if the other trees left exists, and if our new tree has the same left node, or has a left node in this location as well, we are just going to simply increment the value of our left node in our new tree by the value of the other tree. And then else, we say we're going to create a new node in the left side. And then the value of it is going to be the left. Right? And then similarly, we do the same thing for the right side, and then I can just easily copy paste this. Because the same logic, I just need to change the variables a little bit. So here will be right, 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 and right. Cool. And now we did that right, and now we're going to repeat the same thing for all the way down the tree. So we're going to traverse the roots left and the other trees left, and then we're going to traverse the other trees, our root trees right, and the other trees right. This is basically a void function, so it doesn't return us anything because we're actually modifying the root in memory. But up here, we also need to call the traverse helper function. Oops, I should call it helper, right? That might be the bad name for it. I just call it traverse. That makes a lot more sense. So we're going to traverse here as well, starting from the root to tree 1, and then going to traverse over something for T2. And then at the result, our whole tree should have been updated, and we can just return the top of the tree, which is the root here. And then let's see if that works. All right, translating it. All right, cool. Yeah, hopefully that was helpful, and see you guys next time.